The true battleground for ethical AI isn't solely in complex algorithms, but often in the seemingly benign act of data sampling. We implicitly trust our random selections, assuming they neutralize bias, a profoundly naive view. Consider stratified sampling, hailed for ensuring proportional representation within known subgroups. Yet this precision can be a trap. If those very subgroups are themselves products of systemic historical inequities, then faithfully reproducing their proportions merely entrenches these disparities into our predictive models. It becomes a high-fidelity statistical mirror, reflecting a flawed societal reality, not correcting it. Imagine a hiring algorithm trained on a decade of company data, where leadership roles were overwhelmingly male, stratified sampling to preserve male-to-female ratios in the training set, while statistically sound, ensures the model learns to associate leadership with maleness, perpetuating a discriminatory pattern. The algorithm becomes a proxy for past human bias, amplified. This isn't about isolated data points. It demands a critical socio-technical examination of data provenance. We must ask what historical forces shaped this data distribution, what power dynamics influenced its collection and categorization. Ignoring these questions transforms data science into a sophisticated method for automating prejudice. Traditional statistical sampling prioritizes efficiency, minimizing variance, but the emerging discipline of fairness-aware machine learning pivots. It introduces granular metrics like demographic parity or equalized odds, demanding models perform equitably across sensitive attributes, even if it means a slight trade-off in raw predictive accuracy. Python ecosystems are responding. Libraries like inequities and fairlearn provide frameworks to audit models for bias post-hoc, revealing disparities across groups. However, the most impactful interventions occur much earlier, in the design of data collection. This involves active reweighting of samples, generating synthetic data with specific fairness objectives, or even deliberately oversampling historically marginalized groups to counter ingrained deficits. The profound insight: our sampling methodologies are not value-neutral mathematical procedures, they are ethical design choices. Understanding that data scientists must transition from purely statistical rigor to an ethically informed criticality is the cornerstone of building truly responsible and equitable AI systems.